Okay, to finish off this HRV duct sealing video series, thought we'd get a little bit up close for showing how I detail these. So, I found that the Ys were quite susceptible to, and especially when it was a fairly small branch coming off of the main line, they were susceptible to opening up along these seams. So you can see I've already taped off about 75% of this. Taped off these. These are heat rivets. This may look like it's airtight, but it is not. It is a loosely welded seam. Same with these kinds of things. And these heat welds are just here to keep this closed. It has not at all been made to be airtight. So you definitely want to seal these up prior to installing. But I'll show you some of the tricks that I've come up with on the Ys. First of all, I like, and you should be able to hopefully see that inside, I like to seal up the inside of the Ys. And I'm going to, hopefully this turns out on the video. But I find that the inside of the Ys are much easier to seal than the outside of the Ys. And that will perform sort of a secondary air barrier. You want to make sure your tape is tight, so obviously it's not flapping, but this takes about 30 seconds to do, where the outside takes about probably 5 minutes or more to do. And I'll show you some of the tricks I've come up with. So this is fairly easy. You're basically pushing the tape into the seam. You'll have a much easier time if you have more tape on one side of the joint than the other. If you try to split it down the middle, you'll just end up tearing. But at some point you get to the point where you can't easily bend, obviously, the tape around the corner and get it tight into the seams. So what I like to do is, at that point, I start going this direction, and I also use the backing that the tape comes with as a barrier to it sticking on one side of the joint until I'm ready to apply it. So the way that goes, I wrap it around my tool, and now I can push it down into that crevice without it sticking to the far side. And it's a little bit awkward here because I'm trying to do it for the video, but now this side is nice and tight, and I'm able to bend this around. See, if I didn't have this backing paper here, this would have already stuck to the wall, and there's no way I could get that tight down into the crevice. But because that backing paper is there, now I can just peel it off. Oh, except I used the wrong side. So that didn't work. Let's try this again. See, everybody makes mistakes. And actually, that's the first time I've done that, thanks to video, Murphy's Law. So let's just clean this up and try that again. I'm going to leave that in there and try this again. Okay, so we want the shiny side. Okay, so again, a little bit awkward because I have this in a position that you can see, but I have to kind of reach for it. Stick it down and rock it. Now it has this naturally worn in concave, which is actually quite helpful. So now I'm pretty much guaranteed that that's in there. I'm going to adhere it to the one side, and now it's just a simple matter of moving that, and it's already down in the joint. Slide it up on the other side. And we're going to just do a series of those until we are all the way through to the other side. Shiny side out. And I'm just overlapping by about half the thickness of the tape. Okay, so again, seal one side, we're already pushed down, and boom. Now I find that the top piece, you're not going to get it to go down both sides. So at this point, I do let it rip. I'm just after basically from here to there. And my next overlap piece will go from the middle line to here. And you probably can't see that video, but that in the video, but this is now nicely sealed. Shiny side out. Tuck her down in there. Let me just get that back here. Rock a little bit to, because basically what you're getting is it's going to get extra on both sides and sort of compress in the middle. Adhere to the one side. Pull that back, and boom. Now you've got a nice detailed branch. So I'm going to polish this off, and then I'm going to show you the reinforced ducts. Okay, I should have said reinforced branch, not ducts, but so I have finished taping off all the joints on this. Again, this and this side I've figured out that I can seal in place. I have full access to the full perimeter, but I've taped up the rest of these areas that I won't be able to get to once it's installed. Now that I've got the tape in place, I am going to put the mastic on. So the full approach that the consultant at EnerReady told me to use was to first tape, then to put the screws in, and then to put the mastic in. And the reason that you didn't want the screws in first is because the tape will often rip around the screws, where if you put the screws through the tape, it'll generally self-seal. The only danger that I've seen, and I've had it probably 10% of the time, as I'm screwing in, the force as it's pushing through the second layer of metal pushes the joint apart and will actually rip the tape. So in those cases, I will then notice that it's happened and put another layer of tape on. In this particular instance, I was trying to flatten this, this reducer was overly crimped, and so the inside diameter was way too small, and it created a bit of an air barrier or an air blockage. So I was putting the screws fairly far out so that I could just get the tip of the crimp and pull it all back into place. And what I'll often do is actually take a hammer and bang the crimps flat again once it's installed in the fitting, just to get a tighter fit. And you can sort of see here, that's indeed what I've done, and with the screws it's pulled it fairly tight. Now this is an exhaust, so the airflow is coming this way, so the crimps are the right direction. For HRV, it doesn't really matter. The air velocity is such that you don't get a lot of turbulence from the crimps. There isn't a lot of activity at the surface boundary of the duct, which is why, for instance, I abandoned my approach to do die stamped elbows. And actually this gives a good opportunity to talk about elbows. So initially I was going to do die stamped elbows that had a smooth interior surface. But again, the blog entry that I'll post a link to at the bottom of these videos, it will have more information on some studies that I found that showed that the boundary layer touching the actual metal does not have a lot of movement and does not represent any significant resistance to airflow. So the next concept that does make a big difference, and the study goes on to talk about this, is the difference in airflow between a standard diameter bend radius and a 2 diameter bend radius. So I believe these are 1.5 diameter. They might even be 1. But this is a 2 diameter. Same size duct, but you can see that there is a much gentler curve to the 2 diameter bend radius. Now, fitting this into your assembly isn't the easiest either, and you have to plan ahead in your framing to figure out how you're going to have this size of bend radius. But you can imagine that air coming through here is going to have a much easier time and a much smoother journey than slamming off the back of that wall and almost making a 90-degree turn. These are basically barely better than a mitered 90. Okay, so we've talked about that. Let's get back to our why. So the tape's on. Now I am going to quickly load up some mastic on it. And I'm going to put it on fairly heavy. My consultant did recommend putting the mastic on quite heavy. Not for air sealing, but for strength. Again, the total assembly here that we're going for is one that's airtight, but one that's also strong enough to resist movement over the lifespan of the system, and that could be 50 years. So you definitely don't need to skimp on it. Again, this is definitely fiber reinforced, but I'm going to show you in a second that we actually do another layer of fiber reinforcement. So let me just slab this on. And I just keep a brush in a bucket so that I've always got it ready to go and I don't have to clean it every time. And the concept is to get to the bare metal on each side of the tape so that even if your tape ended up having some issues, you've got a continuous air brake, air barrier from one side to the other of the joint. Okay. Okay, so at this point, a lot of people would just leave it. Again, I found that when I was moving assembled components, or sub-assemblies, let's call them, that just the weight, now I'm working by myself. It would be better if I had 2 people or 3 people on some of these large pieces so that every component of that sub-assembly could be held independently. But I'm not, I'm working by myself, and I think a lot of people would be. I found that the flex was causing some of these branches to open up. So what I like to now do as well is take some of this this drywall mesh tape. I don't like it for drywall. I found that it didn't have a lot of strength on drywall seams, and then if your seam cracked, it was impossible to remove this because it's just individual strands. I did a ceiling once where I was going for a semi-gloss flat ceiling. It was a north exposure. We were bringing in we were trying to bring in more light, and I used this product, and there was some shrinkage in the wood, and the seams all cracked, and I then was unable to pull this out and had to end up furring out a much wider seam by putting paper over top and then furring that out. But for this, I find it works quite well. It's nice and strong. There's fiberglass mats that you can also use, but I find that that this works just fine. And I just cut it into various sections, and basically you lay them in and overlap them, and then it's just a matter of you've pre-buttered it. Now you just tap it in, and then just take some additional mastic and cover them over. And again, when you get to the top, you want to change direction now, because it's going to be too hard. I can probably do one more longitudinal. You can see there it's already started to be a little bit more difficult. Okay, but when it gets to the top, you want to switch directions and do that way. That way you're dealing with a much narrower portion that needs to wrap around. And really, that's it. That's as easy as it is. And when that dries, you can refund that pretty good without there being a problem. So I'm going to continue that off camera. There's one more thing I wanted to talk about, and that is cutting ducts. So I have seen a lot of people putting these things in. So I used to do home inspections, so I would see the end result of a lot of work. I've also been sort of keenly interested in construction for many years, and I go to a lot of construction sites while they're under construction. I've seen a lot of people, they will go and they will try to cut a duct to length using this, and basically they're just hacking it. And yeah, you can get it done over time. It takes much longer. It looks like crap, and you don't get a nice interface where it fits over top of the crimps. So what I like to do is use a angle grinder, and bear with me a second, I'll show you what I have. So I've got an angle grinder, very thin blade. This one is meant for stainless steel, so it works well with galvanized as well, thin galvanized. And so it's a matter of you've measured it out, now you need to cut it. And I've come up with 3 different methods depending on the size of the duct that I have and what I have for marking. The easiest is if you have a clamp that is the right size and can go down small enough, you just line it up with your mark, and you can then very easily see that it's sort of square. You have a nice perpendicular cut, and then you just take a felt line around and mark it. So that's sort of the premium version, but you have to have these cable clamps in a whole bunch of different sizes so that they'll actually close down on the duct size that you're cutting. Another method I came up with is just some zip straps, and it's pretty easy to see that they're in the same plane, and then again you just take a felt and mark it off. And then if you don't have that available, you can take just a standard piece of duct that has at least one good side, and this side, when I put it together, had a reasonably good flat face. Pull it apart. Take the side that has the I don't know how to say it, the flat blade that is the backing for the other side. Take that, and you can just push it into the crimp and put it obviously at the right mark that you're wanting to cut off of, but by having this a little bit wider and pulling it around, it will basically center itself. And then again, you're just marking around. Obviously this can go quite a bit different sizes, and as you pull it tight, it will automatically end up with a nice perpendicular cut. So that's it. These are some of the tips that I have come up with over the last couple of weeks installing my system. Some of the recommendations done by my consultant. Some of them are in the paperwork provided by Eneready, David Hill. If you're interested in seeing the end result of my air testing, I will obviously be having the system duct blast tested. I'm aiming for zero air leakage, which has only happened once before in my consultant's testing past. I think it's doable, but I'm a little bit worried now that I've seen today's testing results as demonstrated by these videos, but we'll see. If you are interested, please go to my website and subscribe to my journal entries. I will be talking about it following up on the journal. So thanks for visiting, and we'll see you next time.